slope-intercept form of an equation of a line. Right? So when we solve for y, and we have a linear equation, we solve for y, we have our equation in slope-intercept form. So an equation of the line that has a slope m and a y-intercept b is y equals mx plus b. Right? So slope-intercept form isolates y. We write the x term first to represent our slope, and then the constant second to represent the y-intercept. So let's look at these examples here. We're just going to, we have all the information actually just to write them into slope-intercept form, or to find the slope and y-intercept given the line. So A there, find the equation of the line with slope 3 and y-intercept -2. Right? So because we've got the y-intercept and not just any point, we can go right to writing this in slope-intercept form. There we go. All right, so slope-intercept form is y equals mx plus b. In this case, m, the slope is 3, and the b, the y-intercept, is -2. So our equation will be y equals 3x minus 2. That's all there is to that one. Find the slope and y-intercept of the line, 3y minus 2x equals 1. So for this one, we need to isolate y. So we have 3y minus 2x equals 1. Let's add 2x to both sides. So that's 3y equals 2x plus 1. And then our final step is to divide everything by 3 to solve for y. And so our equation in slope-intercept form is y equals 2/3 x plus 1/3. Now that we've got it solved for y, we can easily identify the slope and y-intercept. Slope is the coefficient on x, so the slope is 2/3. The y-intercept is the constant that's added in. So the y-intercept is 1/3. We could also write that as a point, and as a point, that would be the point 0, 1/3. The x-coordinate would be 0, because the y-intercept is the value of y when x is 0, and the y-coordinate would be 1/3. Right? And that's all there is to rewriting an equation into slope-intercept form, identifying slope and y-intercept from an equation in slope-intercept form, or writing an equation in slope-intercept form given the slope and y-intercept. Let's do one last thing. If you remember in the last video, we had these two equations. They are different but equivalent for an equation of a line, and they're written in point-slope form. Let's simplify to slope-intercept form and see if we indeed have the exact same equation. All right, so let's look at the first one. The first thing we need to do is distribute the 3/2 to both terms in the parentheses. So that would be y minus 2 equals -3/2 times x is -3/2 x. -3/2 times 1 is -3/2. Now we want to solve for y, so we're going to add 2 to both sides, but we do need a denominator of 2 on the right-hand side, right? So 2 is the same as 4/2. So that gives us y equals -3/2 x. -3/2 plus 4/2 would be plus 1/2. So this is the equation in slope-intercept form. Let's find the equation in slope-intercept form using the other equation in point-slope form. Again, we'll distribute the slope. So y plus 4 equals -3/2 times x would be -3/2 x. -3/2 times -3 would be a positive 9/2. Right? Again, we need to isolate y, so we're going to subtract 4 from both sides. But over here, we need a denominator of 2, so we can combine it with the 9/2. 4 is the same as 8/2. So that gives us y equals negative 3/2 x. 9/2 minus 8/2 is 1/2. So notice we get the exact same equation, right, showing you that yes, indeed, those two equations were different but equivalent. And from here, we can easily identify the slope and the y-intercept. Right? So we could identify the slope really easily in point-slope form too, but not the y-intercept. So in both cases here, I'll put it over here right in the middle, because this is the same equation. Our slope is negative 3/2, and the y-intercept is 1/2. And we could also write that as a point. That would be the point 0, 1/2. All right, and that's all there is to writing equations in slope-intercept form. All right, now we've done it a couple different ways, from information and from an equation in point-slope form. All right, thanks for watching. Bye for now.